Namaste everyone, and welcome back to our Java programming journey. Today, we are diving into a super important and powerful concept, Java generics. If you have ever struggled with class cast exception, or wished your code was more flexible and type-safe, then this tutorial is exactly for you. Generics help us write code that works with different types of objects while ensuring type safety at compile time. This means fewer runtime errors and more robust applications. In this video, we will understand what generics are, why they are essential, how to use them in your classes and methods, and finally, look at some common mistakes to avoid. By the end of this session, you will have a solid understanding of how to leverage generics in your Java projects. So, let us get started, my dear students. Alright, let us start by understanding the problem that generics solve. Imagine you want to create a simple container class that can hold any type of object. Without generics, a common approach is to use the object class. Look at this myObjectContainer class on the whiteboard. It stores an object, which means you can put anything into it: a string, an integer, a custom object, anything at all. But here is the catch: when you retrieve the item, it comes back as an object. You then need to explicitly cast it back to its original type. If you accidentally cast it to the wrong type, for example, trying to cast a string to an integer, the compiler will not complain, but your program will crash at runtime with a class cast exception. This loss of type safety and the need for explicit casting make the code error-prone and less readable. This is precisely where Java generics come to our rescue. Now, let us introduce the star of our show, type parameters. Instead of using object, generics allow us to define a placeholder type, commonly denoted by T for type, or E for element, or K, V for key and value. Observe our myGenericContainer class on the whiteboard now. Notice myGenericContainer T. Here T is a type parameter. This means when you create an instance of myGenericContainer, you can specify what type T should be. For instance, new myGenericContainer string creates a container specifically for string objects. The beauty is, the compiler now knows exactly what type this container holds. If you try to put an integer into a string container, the compiler will immediately flag it as an error, preventing runtime issues. And when you retrieve the item, it is already of the correct type, so no explicit casting is required. This gives us compile time, type safety, and cleaner, more readable code. Isn't that fantastic? Let us move on to a practical example to see generics in action, including generic methods and bounded types. On the whiteboard, we have a generics examples class. First, observe our printArray method. It is a generic method denoted by E before the return type. This method can print any type of array, integer arrays, double arrays, you name it, without being rewritten for each type. This demonstrates excellent code reusability. Next, look at number container T extends number. This is an example of a bounded type parameter. It means T can be any class that extends number like integer, double, float, but not string. Bounded types provide more control and ensure that the generic type satisfies certain criteria, adding another layer of type safety and constraint. This makes our generic solutions even more robust and specific when needed. You can see how we use both in the main method and how trying to create a number container with a string would lead to a compile time error. While generics are powerful, it is easy to stumble upon a few common mistakes, especially when you are just starting. Let us look at some of these and how to avoid them. On the left side of the whiteboard, under Common Mistakes, you will see the first one, using primitive types with generics. Remember, generics in Java only work with reference types, not primitives. So, you cannot use list_int, for example. You must use its wrapper class listInteger. This is a very frequent error. Another mistake is ignoring raw type warnings. If you use list instead of list string, for instance, the compiler will warn you about using a raw type. While it might compile, you lose all the compile time type safety that generics provide, defeating their purpose. Always pay attention to these warnings. On the right, under Best Practices, the tips are simple. Always use wrapper classes for primitives in generic contexts, and always specify type arguments to leverage full type safety. Following these will save you a lot of debugging time. Alright, my dear friends, we have covered a lot in this short tutorial. Let us quickly recap the key takeaways about Java generics. We learned that generics provide compile time type safety, which means many errors are caught before your program even runs, preventing those nasty runtime class cast exceptions. They also promote code reusability, allowing you to write flexible algorithms and data structures that work with different types without duplication. We saw how type parameters like T are used to define generic classes and methods. And we touched upon bounded types, which let you restrict the types that can be used with your generic code, making it even more precise. Remember, practice is key. Try converting some of your non-generic code to use generics. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming lessons. Keep coding, keep learning, and I will see you in the next video. Jai Hind.